The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, good morning, good evening, wherever you are in different parts of the world. I hope you're all healthy and safe and happy. Given the current situation in the world, everybody's facing challenges, and I'm sure each one of you is doing a great job of dealing with it. We have another one of our exciting IFEAS GDC IUC webinars, and let's see if I can get that. Yeah, you can see the screen. As you can see, the details have been sent to you earlier. This is actually the first of a three-part webinar series by this group. It's on problem-based mega projects, complex problem-solving competencies, and interdisciplinarity in higher education. Dr. Annette Kolmos is their fearless leader who's done fantastic work over the last several years in this area of problem-based learning. And of course, she's at Aalborg University in Denmark, and she has a team of people, and one of her brand new assistant professors, Likhi, is going to be part of our team for today, presenting today. You have seen the abstract, and here are some details about the distinguished career of Dr. Annette Kolmos, and I will not take away from her presentation by reading through that. And then we have Dr. Likhi Bertel is also with us today to be part of this presentation. So without much ado, I'm going to hand them over to her. So please, as usual, text your questions or comments, and after about 35 minutes or so, we will start responding to them. So with that, I'm going to give the screen back to Annette, and she has to just click show my screen and ready to go.
Okay, thank you very much, Krishna. It's really a pleasure to give this webinar, I would say, on problem-based mega projects. And I'm so happy that I'm here together with my colleague, Lykke Bertel, who is our new incoming associate professor at the UNESCO Center in problem-based learning. We want to address today variation in different ways of running actually PBL. And mega projects is the last type of project that we are trying now to integrate into engineering education. And we will tell more about also a research project that we have concerning these mega projects. And this is the research that Lykke Bertel is doing right now. So let's get started. Okay, thank you. The learning from this webinar, the first point will be to bring in more variation in the learning methodologies. We know from research that when students they learn in different ways, they can also start to reflect on different learning strategies, and it's very important for students actually to be able to experience themselves in different settings. So the reflection on variation is very important, and that's also a way to create personal learning tracks, or what you can say lifelong learning strategies. The new word for this is personal learning tracks, where you have the whole life to create your own competence development, and you can do that from both formal and informal settings. The third learning would also be to develop at a system level, or at least across the courses, and this is what we will get back to. So when we say apply variation in PBL, it concerns both the problems, the projects, and the degree of interdisciplinarity and complexity. And a recent review that was published in the European Journal actually indicated quite clearly that the way and the most common way that PBL is implemented in engineering education, it is at the course level. So this is also why we keep arguing that if students, they really should learn from PBL and the variation in PBL, we also need to have a system approach for that. The challenges are lining up, I think, and I don't think we should use very much time for this, but there's no doubt that the corona is a huge challenge, and we have moved from complexity to chaotic situation, I would say, all over the world. It also has resulted in an overnight implementation of digital learning and also digital conferences. And I hope that after this period that we will start actually to rethink and to use our experiences. And of course, we have the climate change, the sustainability, and all the SDGs from the UN, the Sustainable Development Goals, and all the challenges that are related to these areas. And we have the new emerging technologies coming up, and how do we actually integrate that into engineering education, both with artificial intelligence, the Internet of Things, virtual reality, and others. How can we use that? It might not be enough just to implement another course. It might be relevant actually to try to do it in different ways. So challenges in higher education or in engineering education. So what competences are needed? What ways can we find to integrate and address systems thinking? And how do we educate for lifelong learning tracks? And the first question you can say you would ask is student-centered, problem-based and project-based learning then the answer? And is that the answer for both learning content as well as collaborative competences? I would say it depends. And it depends, it might be a yes, if there is a variation in the learning experiences, both concerning problems, projects, size, time span, etc. Then, and the students have the ability or the possibility to reflect on the learning process and to compare the experiences across team, across the semesters, in the curriculum. Then it might be an answer, and because and we will come back to that during the presentation. But just having PBL in one course, it might not be the answer to all the challenges that we have. It needs a more comprehensive approach, a more comprehensive way of addressing the challenges. And there's also a need for a strategy for integrating future orientation. I think our engineering students are looking far much backwards, and we are not really training our students to look forward and to see how they can deal with the different technologies. There are different types of problems and strategies for problem analysis. It can be an unsatisfactory situation where you have a bottom-up analysis from practice to technology. And you can see that on the picture, there might be disabled people, and they have a huge need for reading or a huge need for some audit technologies and so on. Or it can be an unutilized potential, that you have a technology and you don't know where you can actually really, maybe it can be used in new settings and to solve new problems. But it's also important to look at, when you look in a problem analysis in PBL, to look at the unknown impacts. And it's both from what are the consequences actually from technology and within. So what are the consequences when you are using the technology? What type of how will it impact society, the social relations, poverty, all the SDGs? You can run through them. So there is a variation in problems also concerning who are defining the problems. So very often when you have discipline projects or you have PBL projects within courses, these problems are teacher driven. But when you have problems that are more open, that are more where the students are identifying problems, where they really want to do a new innovation project, where they have unsolved situations, it can be much more student-driven. So it is on the horizontal axis, it's a question of how open are the problems or ill-structured, or how narrow are the problems or well-structured. When we talk about variation, we actually say that it's very important that students, they are trying out both type of problems. So it's not only the narrow problems they are trying to solve, and narrow problems often goes together with more limited discipline objectives or learning outcomes. But it's also important that they try out to identify the problems by themselves, and that is part of the whole innovation competence. We also brought up the Cynefin framework, where we have 4 types of problems, you can say, or 4 types of approaches. We have the simple, that is very much the discipline approach. We have the complicated, or you can say in the simple, you know the problem and you know the answer. So it's what students need to learn in the discipline. You have the complicated, where you know the problem, but you might not know how you will actually construct the solution. So maybe it's a bridge, you know all the components, you know what it takes, but you also have to situate it at a special place. And then you have complexity. And complexity, it is much more about where you don't know the problem and you don't know the solution. So you really need to start out by studying, by figuring out what are the problems. And then you have the chaotic. The chaotic can be very hard to bring into to education. But what we try now at Aalborg University, it is to bring in complexity. And students, they also need to learn to deduct from complex to complicated, and even down to something that is simple, to some discipline problems they can solve, and then with an induction back again to the complexity. They need to know when they do minor problems, minor projects, they need to know what is the more holistic picture. So we have also a variation then in projects. So we have 2 axes here in the projects. We have teams and network on the one side, and we have interdisciplinarity on the other side. And if we have less of both, we would call these projects for discipline projects. If we have more teams and network, bigger groups, but we are still within the discipline, we will call it multi-projects. And we will go through and give you some examples. If we have more interdisciplinarity, but less in teams, we have interdisciplinary projects. And then we have the new area that we are about building up with a narrow and broad interdisciplinary megaprojects. Just to give you an example of a discipline project, this is from electronics. It's the students, they have to learn control theory, and they do it by having a problem, going out, looking at a problem at the harbor side, where they have to build up an anti-sway system for a ship to shore crane. The issue, if you don't can build up this system, is that of course when these what's called containers get into a sway, it will be very dangerous for both the crane but also for the people around them. So this is, you can say, a simple, narrow problem, but it's relevant for the students to learn about this and also to learn the knowledge. The multi-projects, that is for teams of, you can have 3 to 6 people in the teams, but you can also, there are plenty of teams. It can be up to 10 groups working on the same app. For this, it's just an example where they are working on an app for autism, and they have actually have the same project for many years, but they are developing the app the whole time with new functions. And then in computer science, you are getting new new languages, new ways of coding, new ways of building up apps, so new interactions and so on. So all that has been, but the stakeholders, the actors within the around these projects are more or less the same, and they have a very close collaboration with the organization for autism here in Denmark. If we go to the interdisciplinary project, this is one group working. And for example, it can be in media technology, it can be where they're working on a sustainable city game designed as a medium and catalyzer for learning activities within school. So this group will go out and they will have to analyze what are the pupils doing at the primary or the secondary school level. What is it? What are the end users? So they have to learn something about that, together with, of course, all the technology and the coding and everything what they're going to do. So you bring in more disciplines within the same group or within the same program, actually. That's also a part of interdisciplinarity. And then we come to the megaprojects. And we have some narrow and broad interdisciplinary megaprojects. And I think it's very important to distinguish between the two, because you can say that you have the disciplinary and multi-projects. And for students, it's actually quite a simple communication and collaboration, because they are working on the same product, they are working within the same paradigm, and it's more easy for them actually to learn to do the project management and to collaborate. In the narrow interdisciplinary projects, it involves disciplines with more or less the same paradigms. So it can be within biotechnology and chemistry and biology and maybe civil engineering. So they share the paradigm. So maybe it's complicated to communicate with them and collaboration, but they are still within the same way of thinking. But the broad interdisciplinary project, this is where it's actually getting difficult, and what is also is a good learning experience for learning outcomes for engineering students, because it's an involvement of many different disciplines, and it's a presence of different paradigms where they have suddenly to understand, why is qualitative method something that is worth using? I have heard many engineering students saying something that is not so nice to repeat here on qualitative methods, on interviews, observations, etc. But it also gives a much more complex communication and collaboration, and the project management will become much more complex. Just for very shortly, narrow interdisciplinary megaprojects, this is where they can work on satellites. For example, we have several teams doing that. When first group of teams, project teams, they do the requirements, the second, the prototype, and the third group of project teams, they get the satellite up in orbit and even go to India to follow the satellite, will get on board and follow the process totally. There are a lot of black boxes. When we work with megaprojects, there will be a lot of black boxes. You need to know that there are different issues in the different boxes, but where you go deep, it is in the white areas. It's not in the black boxes. There you just need to know something is there. And now there's also the Industry 4.0, the smart lab working, where students are working on what is called smart production, with robotics, electronics, computer science management working together on different types of projects. And now I think I will give the word to Løkke, because she will say something about our broad interdisciplinary megaprojects.
Thank you, Annette. Yes, so the next step in sort of expanding interdisciplinarity and also expanding this teams and networks approach is to implement these megaprojects at Aalborg University. And the megaprojects are large, ambitious projects that are addressing the SDGs to some extent and other societal challenges. And not all of them, of course, in one project, but a couple of them in each of the mega projects. And so the mega project as a whole consists of many semester projects spanning 2 to 3 years. And all of these different semester projects will contribute to the overall solution of the mega project challenges. I'll get a little bit more into detail about how it is organized. So the characterization of these projects is that they're highly interdisciplinary and that they extend over an extended period of time. And of course, that also requires the students to interact more across disciplines and also to share knowledge into also across paradigms, as Annette was explaining. And the final part of that is also to involve external partners. We do that in all of our project types, but it's a requirement in the interdisciplinary mega projects that we have a large involvement of the community, both locally but also globally. So this is sort of the conceptual structure of these 4 mega projects, where we have the sort of the top level is the mega project and related SDGs, and then sort of dividing into up to 3 focus areas for each. And I'll give a couple of examples later on. And each focus area can then have maximum of 2 challenges, or sort of initial problem statements, you could say, that groups of students can work on. And in this relation, it's a requirement that the mega project addresses at least disciplines from 4 faculties. So it's quite ambitious in terms of interdisciplinarity, but it doesn't have to be throughout the challenges as well that all faculties are involved. So they can become a bit more narrow in the interdisciplinarity. The focus area has to be relevant for these 3 faculties, and then challenges for these 2 faculties. So this is what a mega project would look like. You have clusters of up to 5 student or semester groups. Each semester group is a group of students from 4 to 7 students, depending on size, but there could also be master thesis where it's just 1 or 2 students. So they're quite a variation there as well. So clusters of up to 5 groups of students in each challenge, and there can be sort of not a limited number of clusters for each challenge. So as you can see, it's quite a complex construction of challenges, but the point here, or the important part, is that we seek to expand interdisciplinarity also within each cluster, so that students are encouraged to interact, collaborate with students from other disciplines and other research paradigms as well. There will also be clusters with more students from the same study program, but different levels. So you have 7th semester or 2nd semester students collaborating. And that is also something we've been looking into, and how that facilitates collaboration and interaction. So just a brief overview of sort of the difference between what we've done in the past and what we still do in many of our programs, and what the new is in the mega projects. So whereas the regular PBL project will address fairly simple to, or at least with a limited complexity in real world problems, to significant complexity, significant societal challenges that one semester project wouldn't be able to address on its own. We have multiple disciplines and in clusters of groups of students, and we have varying semesters also participating at once. And mainly the biggest problem right now is actually the expansion of a project across semesters. So how do we actually make sure that each project group delivers on the learning outcomes while also taking part in a project that continues after they've delivered their part in contribution to the project? These are some of the tools we use to sort of facilitate collaboration, to facilitate knowledge sharing in and between the groups and the clusters. So the students are part of a project where they deliver something and deliverables throughout the project period, and there's also joint deliverables. There's events throughout the the project where the students come together, and we've both observed that in physical settings where the students can meet. We did that last year, and then this year we've been meeting online and in different blended modes. So we've also looked at how does that really affect the collaboration and the interaction between students. And then finally, there's a MEGAPROJECT conference where the students present their sort of shared joint contribution to the MEGAPROJECT and sort of pass on the project to new students. Yes, and there's also some content that's delivered to the students as part of this, courses on SDGs, on digital supported project management, and so on. This is just a brief timeline. I think I'll just skip. You can see that there's a timeline here. It's quite complicated to make sure that there's this collaboration. So it's not something that just happens naturally. We have to facilitate it in some way. So these are the examples from both from this year, from this spring. We did also do some studies on the MEGAPROJECT that started in the fall, and I'll just briefly introduce these projects and then some findings we have from the research. So as you can see, both these projects here are related to the SDGs and addresses several of the SDGs. But then, as you can see, they sort of split out into different focus areas, different challenges that then each cluster of students will address in different ways depending on their disciplines and sort of the interaction between the discipline in each cluster. So all of these are related to the sustainable living approach, but we have, for instance, a large cluster of students working on the challenge of eating sustainably and what does that mean. And that's actually spanning both all the way from food production and to consumer approaches and how to understand what consumers decide when they buy food. So there's quite a lot of complexity also within each cluster. This is the other example, the circular region, which has a very regional focus on northern part of Denmark and where Aalborg University is, and addresses different challenges related to facilitating or improving the sort of circular approach to in the region. And we have different challenges there as well, with different disciplines addressing these different focus areas. So what we've been looking into in the research for these first two rounds of megaprojects at Aalborg University is to first understand, of course, potentials, but also challenges related to this implementation of these new projects. And especially now with this very rapid need for blended and online learning, how does that affect these large, very complex projects? Both from the students' perspective and also from facilitators' perspectives, and of course also from an organizational point of view. As part of this research, we have both been looking at these produced documents, deliverables, and synthesis across the projects, and we have been looking at the events where students meet. We've observed them both in physical settings as well as virtually. We've been using Microsoft Teams for this, so we've been in there when they've met up to 20 students discussing different projects aspects of their projects. And then we are doing, right now, we have done some interviews and we're still conducting interviews with participants. So just briefly, there's lots to say and I won't go into too much detail, but just some preliminary findings we've seen is that these increasing the complexity in these projects really both require but also facilitate new competencies related to collaboration, but also to understanding interdisciplinarity and the quality of interdisciplinarity in relation to your own discipline. So that's a big part of why we're also doing this. But what we've also seen is that it requires quite a lot of facilitation. It's not something that just happens naturally. We do need to facilitate this just as we would facilitate a regular PBL project. And especially in the early stages of the project, where the students are defining problems, where they're exploring problems, we really need to ensure that there's interdisciplinarity and there's collaboration across groups, because it's very difficult if we get too far into the project period to sort of make up the collaboration or the interdisciplinary problems. What we've seen is that there's definitely a potential to expand the perspective from the student's perspective on complex problems, but it's also a very uncertain project to be part of as just one group of students, and it can be frustrating to not have the full overview of the mega project and my part as one person or as one group in the contribution from this project. So that's quite an important part of the next steps to ensure that the students understand their place in the project. Yes. What we've seen also with the digitally supported project management now with this COVID-19 and this spring is that it does make it more complex for sure to do all of the project management online, but there's also some benefits of it. It's easier to share online. It's more natural now for the students to share with each other because they're working online anyway. So there's definitely some potential there, but we need to facilitate the workflows more. And then finally, what we found is also that it's very important that there's sort of an anchoring at institutional level, and that all of the facilitators recognize and prioritize the facilitation related to being part of a mega project, and not just that you have a discipline and you have an exam and you have learning outcomes that relate to your own study program. So balancing the interdisciplinary scope of the project with learning outcomes in the formal curricula is really important. And now I'll hand the computer screen back to Annette for the final and closing comments.
Yes, thank you, Løkke. And so the last part here, it's more to compare actually and the learning outcome, you can say, from a narrow interdisciplinary and broad interdisciplinary approach. And for engineering students, it might be easier with a narrow interdisciplinary approach because they can work on a common product. And the product piece is important in engineering education. So whereas the broad interdisciplinary approach, maybe you have clusters of product groups who can work on a common product, but as far as we have seen the development right now, it's not what has happened. They have more or less worked on each their project and then they have shared their experiences. But the sharing of experiences, we should not underestimate that because they understand if there has been a group with waste, for example, and there has been a group from economy sitting with the economic around waste and how that can work as a business plan, and we have another group with waste with how can we develop a more technical system for sorting out waste at the different households. They get inspiration from each other and they are working in the same direction, and also the technical part will have consequences for the business model the other students are developing. So they really learn something from each other and opening up their eyes for something that is bigger. It also means that you can say that if we look at the different project types and the different disciplinary and interdisciplinary aspects, you can say that the problem analysis, well, these problem analysis, they are quite different from in a disciplinary approach to understand the discipline domain and how the discipline relates to other disciplines, to actually in the narrow interdisciplinary to understand the problems related to parts of the system, or parts of a process by combining a few core disciplines, which can be extremely important. Even in engineering, we are too focused on silos and too focused on and we are living with boundaries around ourselves. But in the broad interdisciplinary, it's understanding problems in a much more comprehensive system and a perspective by making synthesis of different discipline approaches. And it's not so that we are saying you should only do the broad interdisciplinary, or you should only do the narrow, or you should only do the disciplinary approach. Our point here is that it gives different conditions for learning. It gives conditions for different learning outcomes for the students, and the variation will be something that is very important. It's important in engineering that mechanical engineering, mechanical, electronics, production are working closely together on some aspects. It's also important that students they have an experience from something that is broader than that. And it's not only a course that they have actually participated in, but it's something where they have been working on together with students from other disciplines, from social science or from humanities or something. Also for project management, I think this is very important to emphasize that when you know your discipline, when you know the knowledge field, more or less, it's you have more or less stable teams and stable structures. But in the broad interdisciplinary approach, you go into agile systems, much more flexible structures, ad hoc groups the whole time. And there are even theories saying that we have ad hoc crises in these areas, where you really learn to, then you are in a subgroup, and then you work in another subgroup, and so to combine it. And also for the collaboration from the a bit more simple within the same knowledge paradigm to something with different knowledge paradigms, and this really creates a lot of issues, I would say. And it's if we could work across health, engineering, biology, maybe we could also then come to some kind of a solution to also to some COVID-19. We have put in some references, and I just want to say thank you very much. I hope that you get the point with the variation, and that you have questions for us.
Of course.
Thank you.
many questions, but I thank you very much, Annette and Licky. The fantastic, very inspiring, very in-depth, the thought-provoking presentation. I pulled up a few people for the panel from around the world for discussion. We have the speaker is from Denmark, and I've got Roger Hadgraf from Australia. We have Khairia from Malaysia, Kristen from Europe, and then Susan O from Korea. So Alfred Nogovi from Africa. So we've got a whole bunch of people from different parts of the world here. And of course, Ramiro from New Mexico. Let's get started with Ramiro to make a few comments, and I'll go around the table to see what other people have to say. So Ramiro, you want to just jump in here for a minute, hope so?
Hello, can you hear me?
Yeah.
Yeah.
Thank you. Thank you, Annette. Thank you, Licky, for a wonderful presentation, very enlightening. This falls perfectly with this call to action that we launched in IFES and GDC. We're now really dealing with mega projects, mega problems that we need to think without borders. That's another challenge that we need to bring to the picture. We're treating what we live within borders, and it's a problem that doesn't know anything about borders. So I really like your presentation about systems thinking, complex thinking. Something that is very important to bring into the classroom is called transparency. Once you start dealing with projects, and So thank you. That's all I want to say. Express my thank you to you. Thank you.
Thank you. We also have Professor Su from China. Go ahead, Annette. Any comments before I move on to Khairia? Khairia, come in. You're self-muted, Khairia. Khairia. Okay, let's see if I can get Roger. Roger grabbed.
Yes, there we go. There we go. Thanks, Annette and Luca. That's a wonderful presentation. We've spent plenty of time talking about these things. One of the things that interests me is how much time students spend in these mega projects in actually grappling with the problem before they rush towards finding a technical solution. And I'm just wondering what your observations are so far of some of the groups that you've been observing.
Yes, thank you, Roger. And I agree very much. It's a very important question, and it's also why I've highlighted exactly what you're saying, that they should, especially in the early stages of the project, we need to facilitate more collaboration in the early stages, and also to enhance sort of the focus on the problem and not just going to solutions. So it is a challenge. I will say we've seen that already, that you quite quickly, the students are oriented towards trying to come up with solutions. But it is something that they do spend on up until the second deliverable and the midterm. They do spend time just understanding the problem. Yeah.
Yeah, sounds good. Thank you.
We were able to get Khairia on. I think just almost came on. Khairia, come in again. Yeah.
Hi. Can you hear me?
Yes.
Yes.
Okay. Hi, Annette.
Hi.
This is really interesting. It's really impressive. I can imagine the complexity that's involved in trying to organize the teams of the clusters of students, like you said just now, and in determining how many clusters would you have under specific parts of the problems. When you're arranging the clusters, so I'm really curious, do you assign how many clusters will be under each part of the problem, or does it fall out eventually when the students choose, or is it more of instructor driven by assigning certain numbers of clusters under each the different parts of the problem? How is it organized?
Yes.
Is it more organic, or is there a structure to it?
Yes, so thank you for that very good question. We do emphasize that the students have quite a lot of freedom in choosing the problems to work on in the mega projects. So there is a process from the mega project conference early on to where they have to submit their first deliverable, where that is sort of a project presentation or a project description outline, you could say. So in that process, the students freely choose what focus area and what challenges they want to work on. But then there is a process of sort of figuring out the constellation of each cluster. And in that part, there is that's expert members of faculty from each of the relevant faculty in each challenge who are helping and assisting the team, sort of assigning groups to certain clusters. And some students have also been encouraged to switch challenges if their project fits better within a certain challenge. So I hope that answers a little bit. There's a lot of details, but let me know later on if you need more. I can give you more information.
Okay, thank you, Annette. Thank you, Khairia. I'm going to go to South Africa. Alfred Nagovi, you have a couple of comments already texted. Can you speak them out?
Hello, Anita, can you hear me?
Yes.
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 Okay, thank you very much for a wonderful presentation. I just want to know, how do you prevent loafing by students when they're in a group and you find that they don't have enough time to work on the project? so they depend on the effort of others.
Loafing by the
And
students.
connected to that, how do you, yes, and connected to that, how do you fairly assess students, knowing that some of them put more effort than others?
I think that's, I don't know if you want to, to answer that.
No, start out by
Okay,
answering.
and you can add.
Yeah.
So I think that we have, as part of our PBL practice in general at AU, we have quite a lot of systems in place to assess students in projects, also individually, and it's a great focus in Aalborg University to assess individual students fairly. And I think that's, of course, that's just as important in a mega project, but we haven't seen that there's any sort of a greater, in fact, it's quite the opposite, that the students are more engaged because they choose to be part of a mega project. So we haven't really seen that challenge yet, but it's definitely something that we continue as part of our PBL process practice to have a great focus on.
Very good. Thank you, Aliki. Thank you, Alfred. I'm going to see if our friend from China has a comment. Jengge Zhu, would you like to make a comment or question?
Actually, yeah, this is Jengge from SUSTEP. It's very nice presentation. I think thinking to have a project is good, but I was wondering what really the additional skills you learn from those MEG interdisciplinary project with your narrow interdisciplinary project, because the difficulties to organize MEG project is so much more challenging than you work on the narrow interdisciplinary project, and you almost can learn almost everything because you always have the people from different disciplines, you have teamwork. So you know, maybe the problem is more complex, but you all narrow down the clusters. So what is additional like training you feel to work on the MEG projects as compared to the narrow?
I think it's very much the interdisciplinary part that is important. It's important that students, they learn to see problems from different perspectives, from different disciplines actually, and they learn to see how do they talk about it, how do they think about it, how can we communicate about this. The broad interdisciplinary mega projects, it's much harder to run these than the narrow ones. I fully agree with you, but I think it's important also for future competences that students have had at least one experience in a broad interdisciplinary setting. And I think that this is, if you look at the engineering curriculum in the US, you will see that they send their engineering students to humanities and social science to take credits within that area. What is different here is that so in the US you also have an interdisciplinary approach. What is different here is that they're working on more or less the same type of issues, and that is a difference between because they also then integrated much more into how do I collaborate when you get out afterwards. How do I collaborate with people from different areas?
Okay.
Would you add something?
I think that's a good answer.
Okay.
Okay, there's Christian Williamson. Thank you, Dr. Zhu. Christian Williamson, come in.
Thanks very much, Krishna. Thanks very much for the presentation. It was really interesting. I have maybe two questions. You can answer both or just one. I wondered if because of the structure that you need to support the students, maybe with some coaching or with some feedback, I can imagine that the problems that they deal with come a lot from the outside, from companies or from local government, for example. What kind of success have you had of getting people from outside of the university involved in terms of coaching or giving feedback, and has that been useful, or do you find for the students learning it's actually better for one of the faculty academic staff to be more involved in the coaching and feedback. And I also wondered whether you impose any particular difficulty on the team. You know, was it interdisciplinary, but maybe given that you're raising the bar of the challenge for the students, do you look to make sure that they work in teams with other kinds of diversity to make sure that they are challenged in the way that their team works as well, as the nature of the problem that they're working on?
Let me start out with the stakeholders or with society. We have a long tradition with working with companies and with the world outside the university walls. And people, when students they are working on a project for them, they are really interested in hearing and learning about the result. So they are happy to come also to give them some guidance and to get into dialogue with them. For the mega projects, we have several huge organizations that we collaborate with. We collaborate with the municipality here in the north part of Jutland in Denmark, and with all the different, and that gives us access to not only companies but also a lot of public institutions. And they are interested in all results, and we also have a long tradition for collaborating with them.
Yes, and just to answer the second, or at least try, it's a very complex question as well. So it's definitely very clear that the issues that we see in regular PBL projects with collaboration, with conflicts management, communication, they are emphasized to a certain degree when you're in a very complex network of groups. So what we see is definitely a need for facilitation also in relation to collaboration with outside groups. We've seen a greater need to sort of structure the events where they meet so that everyone is heard and everyone contributes to these events. And also I think the Mega Project Conference, which kind of brings both issues into one, where the students present their findings to outside stakeholders, to each other, to other stakeholders at the university and outside, is really important to see how do we contribute and in this complex project.
Okay, thanks. Question from Europe. We have Rajiv Lal from India. Would you like to jump in? I've unmuted you.
Thank you, Krishna. First of all, I find this is a very, very important subject for discussion, and it's very well presented, because most real life problems are interdisciplinary in nature. They are very rarely, you have very simple problems. So the question I have is that, for complex problems, you would also require some specialized solutions which the students may not be able to develop on their own. So what is your experience in mentoring students to arrive at a good solution?
Yeah, that's a good question. And I fully agree with you. When you deal with complex problems, the students, they might not end up with a solution, but only a part of a solution. So the complexity, both for mega projects and complexity, when you take it into education, when you bring it into education, you have to model it. You have to cut things out, but and to focus on specific parts, because they cannot mega projects. If you search for that, that is building cities, transport systems, etc. And our students are not. We can never bring that into education, but we can bring in the thinking. So we can bring in the awareness that this small problem that they're working on, this is part of something that is bigger.
Mm-hmm. Yes, and I can add to that maybe that one thing we've seen that's very interesting from this first 2 rounds is that actually from the first round to the second one, quite a few contributions from the students actually ended up changing the entire problem or the challenge that was defined. So rather than coming up with a solution, some of the groups actually ended up sort of reframing the entire challenge. And I think that's definitely also a part of being in a mega project, that not only the solutions will change rapidly, but also the problem. And this project has to change with the problem.
Okay, good
Right,
point.
thank you. So from what I understand is that your emphasis is mostly that students should take the challenge themselves, and that's how they have a good learning.
Yep.
It's, yes. What is also important to say here, it is as more complex the student projects are becoming, you need more top-down guidance, actually, because we can only organize this when we have with a central organization that actually goes in and organizes things.
Okay.
Good, thank you. I think what you are doing is very ambitious and very, very interesting.
Thank you.
Thank
Rajiv. Roger had a follow-up question, and I'm wondering if Susan O from Korea might want to say something. Susan? Otherwise, Roger, jump. Susan, come in. Susan O from Korea?
That's quite impressive. I'm not really familiar with the project-based or problem-based learning, but I had learned a lot, especially about the mega project. So thanks for organizing a seminar. I'm looking forward to next 2 seminars following this. Thank you.
Thank you. Roger, come in. You had a follow-up question. Roger Headcraft from Australia.
Yeah, thanks, Krishna. This is a really practical question for you both. And that is, how do you arrange the curriculum across the university, across multiple faculties, so that students are actually free on the same days to actually meet for these projects? That might be a bit of an insight into how your university works compared to many others.
These are some of the issues we are working on.
Okay.
Yeah. It's a good question.
Yeah. I think it helps a lot that we already have so much project work, that half of the students' time is committed to project work anyway. So there is actually quite a lot of the semester that is open for group work. But we have seen a challenge, especially in the startup of projects, because usually our engineering students, they are a little bit ahead in the beginning phase, because they define their problems a little bit sooner than some of the students from social science and humanities. So we have seen quite of a challenge in sort of aligning the process so that all the problems aren't defined ahead for the students in humanities and social science. So it's definitely a challenge. Yeah.
Okay, great. Thanks, Roger. Just one last question from the audience here, which is Shailaja Srivastava. Very important question. How do you start a mega project at a university? What are your tips on starting one of these projects?
Starting one.
Yeah, starting a mega project.
Yeah, but the idea actually, no, we have had these narrow mega projects for a long time, and we have several of them. But then our pro-rector wanted to do something that was more ambitious and more interdisciplinary. So she convinced actually our deans or pro-deans for education at the different faculties, and then they set up an organization to plan it and to get it off what's called, to start it.
Great.
So it has been a top-down process to start it, and I think for mega projects it's very hard to do it only bottom-up. You need the bottom-up involvement, engagement, but you also need an institution to do it.
Great. Okay, so we just have a minute left. I'm going to hand this over to Hans to kind of wrap it up, and also maybe Annette, and Likia, you might want to give us some clue after Hans talks about what the next 2 webinars are going to be about. You have a series of 2 more, right? Hans, go ahead.
Yeah, thank you very much, Liki and Annette. You absolutely delivered the kind of quality, thoughtful presentation that we all expected. We're deeply grateful, the IFES, the GDC and IUCE community. Also a number, and just for all of us to know, I'm very pleased. We have obviously active academic engagement, and of course, Aalborg University is an outstanding, deeply respected university globally per se, but also very actively engaged with other universities that are giving their webinars, such as Sashtek from Shenzhen is joining us, and some of the companies. I'm extremely pleased about that. And the kind of quality that you're presenting is consistent that we hope to achieve for the next year and beyond. We've expanded our number of webinars, including also a series throughout Latin America and the Spanish-speaking world, Spain, on a regular basis to touch on that particular community. Also, I don't want to embarrass Annette or both of you, given the brilliant presentation. Also, Annette has been an important member of the IFES global community and was awarded our Duncan Fraser Award. So we've had a close relationship, and we deeply thank you for giving the next two webinars over the next few weeks. Thank you to both of you.
Thank you, Hans.
Thank you. We're happy to.
Can you give us a preview, Annette, of what's to come in the next couple of webinars?
Yeah, the next one, I think it's Bettina Dahl Sørensen, who will talk about PVL in mathematics. And then Ida Guerra, who is associate professor. Bettina Dahl Sørensen is also associate professor. But Ida Guerra will talk about the SDGs, sustainability, and how that can be integrated by the use of PVL.
Okay, fantastic. We will send you information, details, which dates, etc. very soon. And with that, I want to thank the whole audience. We had about 500 people here with another 100 people knocking on the door but could not come in because we were full. Sorry for those who could not join. Thank you, Annette, and thank you, Likhi. This has been a fantastic presentation, and everybody be happy, be safe, and be good wherever you are. Thank you so much.
Thank you.
Bye-bye.